Hello, welcome to today's class. We are looking at further logarithm, and among the content we are going to cover from this topic are logarithmic and index notation, 2, the laws of logarithms, 3, simplification of logarithmic expressions, then we have logarithmic equations, and then further computation using logarithmic laws. The first item we are looking at is logarithmic and index notation. In Form 2, we learned about indices, and we know how to express numbers in index. A good example is 2 raised to power 4 is equals to 16. This one is an index notation. Then we have the component of this index notation. 2 is the base, that is what was raised to power 4. So this is the base, this is the power or the index, and then this is the result. So now if you raise a given base to a given index, you get the result of raising that particular number to a given index. Now let us see how to write from index notation to logarithmic notation. So this is how logarithmic notation will look like. It is going to be log of a base b is equal to c. So log of a base b is equal to c. A is the result of raising b to which index? C. So that is how we normally write a logarithmic notation. The base is written down here, the result is written at the middle here, and then the power is what we get on the other side of the equation. So in short, to write our 2 raised to power 4 is equal to 16 in what we call the logarithmic notation, this is what we will get. Log 2 base 2. 2 is the base. Log 2 base 2 of 16 is equal to 4. That when you raise 2 to power 4, you get 16. So log of 16 base 2 is equal to 4. Let's see the next example. 4 raised to power 3 is equal to 64. In logarithmic notation, we shall have log 2 base 4 of 64 is equal to 3. So just note that the power that the base was raised will always be on the other side of the equal sign. So log of 64 base 4 is equal to 3. What about 8 raised to power 3? 8 raised to power 3 is equal to 512. So therefore, in logarithmic notation, we shall have log to base 8 of 512 is equal to 3. That will be the correct logarithmic notation. Example 4, 10 cubed. 10 cubed is equal to 1000. Then in logarithmic notation will be log 1000 to base 10 is equal to 3. 6 raised to power 4 is 1296. So this one should be equal to 1296. So this will be log to base 6 of 1296 is equal to 4. I want to believe that you have understood how to write from logarithmic, from index notation to logarithmic notation. Write the following in index notation. Log to base 3 of 81 is equal to 4. So we shall have that it is 3 raised to power 4 is equal to 81. Then the next, log to base 10 of 10,000 is equal to 4. This will be 10 to power 4 is equal to 10,000. Then the next, log to base 2 of 128 is equal to 7. So it will be 2 to power 7 is equal to 128. The next, log to base 9 of 729 is equal to 3. So it will be 9 cubed is equal to 729. The next, log 10, we are not given the base. And whenever you're not given the base, treat that as natural logarithm with the base being equal to 10. So therefore, insert here base 10 because you're not given the base. So whenever you're not given the base, make that particular log to be to base 10. So we're talking about log to base 10 of 10 over given equal to a given number x. So we shall have 10 raised to power x is equal to 10, so that express both sides to indices. So 10 raised to power x is equal to 10 raised to power 1, meaning x is 1. So we shall now have that log 10 in index form, it will be 10 raised to power 1. 10 raised to power 1 is equal to 10. So in a similar way, log 0.001, so we shall have this is same as log to base 10 of 0.001, and this one is same as log to base 10 of 0.001 is same as 1 over 1,000, and 1 over 1,000 is same as 1 over 10 cubed. So therefore this will be same as 10 to power negative 3 is the same as 1 over 10 cubed. So it will be 10 to power negative 3 is equal to 0.001. Let us work on these questions. Find x in the following. Log to base 2 of 64 is equal to x. So the concept that we have just learned about writing from index to logarithmic notation and back will help us to be able to answer this question. So now this one will require us to write in index notation. So the base is 2, the power is x, and the result is 64. Express 64 to the lowest base, to base 2. So we shall have 2 raised to power x is equal to 2 raised to power 6. So in this case, x is equal to 6 because the bases are the same. The next one, log to base 3 of 81 is equal to x. So in this case, our base is 3 and the index is x is equal to 81. Express 81 as base 3, so we shall have 3 raised to power x is equal to 3 raised to power 4. So in this case, x is equal to 4. The next, log to base 5 of 1 is equal to x. So our base is 5, the power is x, equate this to 1. So in this case, express 1 to base 5, 5 raised to power x is equal to, we know that 1, a number raised to power 0 is equal to 1. So therefore we are going to say that this was 5 raised to power 0. And that one will give us 1 because any number raised to power 0 is 1. So in this case, it means that our x was therefore 0. The next, log of 1 over 16 base x is equal to negative 4.